So here's some of the tools and equipment that I recommend that you have available anytime you're working with the boat's electrical system. Various things, tools that you'll need, um, and I'll go through each one at a time. Your best friend is going to be this multimeter, okay, which allows you to test different circuits, even 12 volt continuity and different things. But this is going to be your best friend, and I recommend that you put it in a tool bag somewhere and tuck it on your boat. Um, the next thing that I have here is a little wire brush. I use that just to kind of clean up some connections if they're, say, a little bit corroded or rusted. Other thing that I use is a ratcheting screwdriver that'll fit in some tight spots, because there's not a whole lot of room between the breakers and the main distribution panel. You're going to need some wire strippers, a good pair of crimpers. Okay, that's essential, because what you want to have is some good solid crimps that won't come apart under some type of stress. There's a lot of vibration in a boat, and if you wire and mount properly, it shouldn't be a big deal, but you never know. Here's a tester for 120 volt circuits. It'll let you know if that circuit is live. And here's a little tester for your electrical outlets that you can get from Home Depot or Lowe's or whatever. And you can stick it in your outlet, and the various lights will tell you if there's a fault somewhere: open ground, open neutral, open hot, and things like that. The other things that you'll need are some butt connectors. These are butt connectors, and these are terminal ends. Okay, these are number 10 screws here. There's number 8 screws. There's 5/16. There's 3/8. But the different colors are for the different size and gauge of wire that you might actually put in the connector itself. Okay, pink being the smaller wire, blue intermediate, and then the larger wire being yellow, which does 10 to 12 arc. In addition, the other thing that I recommend is this is just a pretty cheap Harbor Freight heat gun. But these butt connectors and different connectors, they have heat shrink on the ends of them, and I recommend, if you're working in a boat, that you always use connectors that have heat shrink, which will basically seal the connector around the wire, and hopefully prevent water intrusion or any dirt or anything like that from getting inside. And keep your connection protected. These are crimped connectors. They're soldered connectors out there. I like the soldered connectors, but I don't like them. And here's why: is that, and this is just my of one. Basically, I was had done some wiring that I wasn't finished with, and I had a connection on the ground. I must have stepped on it, and that solder inside actually broke, and I lost connection. And it took me a long time to figure out where that circuit was broken at, and it was actually broken at the solder connection. Now, had I secured the wires and elevated them properly when I wired it, I wouldn't have had that problem. But again, in a boat, somebody steps in your engine compartment, you never know what they might step on. So be careful of that, and check your solder connections. If you lose ground or power at some point, always look at your solder connections, and basically take your multimeter and check for continuity on both sides of that soldered connection. All right, so how we're basically going to test this breaker is that you have this pole here, you have this pole here. This breaker is currently in the off position, okay? And we're just going to use one side of this double pole breaker for demonstration purposes. So what I basically do is just put this test lead in here and the other test lead in here, with my multimeter set to continuity. Now, if there's continuity across the switch, I should be hearing a buzzing sound right now. an alarm from the multimeter, okay, but I'm not. And that's because this circuit is off. All right, so this is what happens when I turn the circuit on. Okay, so what we have here is a 10 amp breaker. It's a single pole breaker and has one switch, just 2 poles to connect, not the 4 poles of the dual pole breaker. But right here you can see it says 10 amps. That's flow of amperage 10. So that's a 10 amp breaker. Okay. This will trip at 13.5 amps. So if the amperage in the circuit gets higher than 10, it won't trip until it gets to 13.5 if it's working correctly. Now, if it's not working correctly, it may not trip at all. Okay, but let's test and make sure that this breaker has continuity. Okay, as if you don't have continuity, the breaker doesn't work. So I'm gonna take my test leads. And currently this breaker's in the off position, okay? So we'll put our test leads on and see if we have continuity. So as you can hear, we don't have continuity. We don't have a buzzing sound, okay? Now let's see if when I flip this breaker to on, whether or not we get continuity. And that's continuity through this breaker, okay? Now, this breaker, although it has continuity, is still broken. Okay. What it does is when it gets to the end of its throw, there's no actual continuity, continuous continuity. But that's all that you'll need essentially to test for continuity across the breaker. Okay. There's some other things that may need to be tested that are outside the scope of this video, but that's how you check for continuity.